All right, we're going to work on the second part of our notes here. We're going to talk about factoring out a GCF a little bit more. First thing I want you to notice is I have the distributive property right here, but I've written it a little bit differently. Okay, we've written that distributive property a little bit differently because we're going to use it backwards. Normally we distribute the A and we do A times B plus A times C. We're going to use the distributive property in reverse to factor things. So on this left-hand side, notice we have this common factor of A. Common factor, AB and AC have a common factor of A. So what we're going to do is we're going to take that common factor and we're going to pull it out front. So notice over here, the A is out front. So we've taken the A and we've pulled it out front. We've divided out an A. That gives us a B. We divide out an A from the AC, and that gives us a C. That's the technique that we're going to use. We're going to use the distributive property. We're going to undo multiplication or write it as in factored form. So the first thing we do when we look at example 1 is we look at the two terms of that polynomial and we find their GCF. The GCF for this is going to be 6. Because 42 is 6 times 7, and 6x is 6 times x. So we have a GCF of 6. They have that common factor. We're going to take that GCF, we're going to pull it out in front of a set of parentheses, and inside we're going to do 6x divided by 6 and 42 divided by 6. So what we have is 6 times, well, if we divide out the 6 from here, we get just an x, and if we divide out a 6 from there, we get a 7. Okay? And that is our factored form. 6 times x plus 6 times 7 is 6x plus 42. It works. Example number 2. We're going to take our two terms, 12p and 28. We're going to look at them and we're going to find the GCF. So think about what the GCF is for those two. What's the GCF? Well, let's think about that. 12 and 28 are both divisible by 4. Can we get more? 12 is 4 times 3. 28 is 4 times 7. Nope. Most I can get is a 4. So GCF is 4. I can't get a P because the first term has a P. The second one does not. So greatest common factor is a 4. That's our GCF. Once we have that GCF, we write it down and we factor it out. In other words, we divide it out. When you distribute, you multiply it through. So when we factor it out, we divide it out. We're just doing opposites here. So what we have is 4 times 12p divided by 3 is, 12p divided by 4 is 3p. And then 12p, let me try that again. 12p divided by 4 is 3p. That's this one, is 3p. And then the 28 divided by 4 is a 7. And there's a minus sign in between. And we are done. You can check your answer by redistributing the 4. 4 times 3p is 12p, and 4 times negative 7 is negative 28. Okay, we're going to look at some really scary examples on the last page of our notes. Directions say, factor out the greatest common factor. If the leading coefficient is negative, factor out a negative. If the polynomial cannot be factored, write that it is prime. Okay, so first thing we have to do, we have to find the GCF of these two terms. GCF is going to be 15 and 9 are both divisible by 3. That's the biggest we can get. And x to the third and x to the fifth, that's going to be an x to the third. We take our GCF, we write him down. We're dividing him out. So we need to figure out what's left over after we divide out the 3x to the third. So what do we have left over? We're going to simplify those fractions. 15 divided by 3 is 5. X to the third divided by x to the third is 1, so they disappear. 9 divided by 3 is 3. X to the fifth divided by x to the third is x squared. And we are done. 3x to the third times 5 minus 3x squared y. And if you redistribute, you'd find out that it does work. Example number 4. We have 12z to the fifth and 36z squared. We need to find the GCF. So the 12 and the 36, biggest thing that will divide into both of them is 12. And then the z's, what do they have in common? They have a z squared in common. So we're going to take a 12z squared as our GCF, and we're going to divide it out of each of those terms. We're dividing it out. Okay, lost my parenthesis. So we have 12z squared for our GCF. 12 divided by 12 is 1. Z to the fifth divided by z to the second is z to the third. And then 36 divided by 12 is 3. Z to the second divided by the z to the second is 1. And we're done. All right, example number 5. There is a negative as a leading coefficient, so we're going to factor that out. We're also going to find the GCF and factor it out. So we're going to look at a to the 6th, b to the 4th, the 8, a to the 3rd, b to the 7th, and the 2a squared, b to the 5th. GCF for all that is going to be, well, let's see, 1, 8, and 2 are the coefficients. The GCF there is 1. But then we have to have an a to the 2nd. That's this guy right here. And b to the 4th. So we're going to factor out a negative a squared b to the 4th. So each of the terms we have to divide by negative a squared b to the 4th. I'm going to move down here a little bit. Yeah, I think I need some more room. So this is just finding our GCF. Let's see what we've got. So we're going to take out the negative a squared. So this is all equal to negative a squared b to the 4th times, divide out the negative and our GCF, plus 8, a to the 3rd, b to the 7th, divided by negative a squared b to the 4th, minus 2a squared b to the 5th, divided by negative a squared b to the 4th. Okay, so a little simplifying. So we've got negative a squared b to the 4th times negative divided by negative is positive, and a to the 6th divided by a squared is a to the 4th. B to the 4th divided by b to the 4th is 1. We're good. Negative dividing into a positive turns into a negative, so positive 8 divided by negative 1 is negative 8. And then we've got a to the 3rd divided by a squared, and we've got b to the 7th divided by b to the 4th, which is b to the 3rd. Okay, last one. Negative divided by negative is positive. We've got a 2. A squared divided by a squared is 1, so they go away, and b to the 5th divided by b to the 4th is b. And we have our answer right there. Example 6. First thing we're going to do, we're going to rewrite that in standard form. We like to have standard form when we are factoring. So we're going to switch that around, make it x squared plus 4x. That's going to be important to remember in the next assignment too. Standard form. So x squared plus 4x. So let's look at those terms. X squared is x times x. x, so I have an x times an x. I have a 4 times an x. What do they have in common? They have an x in common, right? So I've got x times x. I've got 4 times x. So I'm going to pull out the common GCF, which is x, the common factor, greatest common factor. Okay. Our GCF is x. They have that x in common right there. Pull out the x. So if I take out one of the x's, what's left? Look, one's gone, one's still left. And if I pull out the x from the 4x, I have a 4 left over. Okay, there's our answer. X times x plus 4. Example number 7. We've got 7x to the 5th. We've got 12y squared. We've got 19d to the 3rd. 19 is one of our primes. So is 7. 7 and 19 have no common factors. So, because our coefficients don't have any common factors, and our variables are all different, we've got x's, y's, and d's, the GCF for this is a 1. And when the GCF is 1, we have nothing to factor out, so we're going to call this guy a prime. And we're done. He does not factor. My pen isn't working super well. Could you tell? He is prime. That's what I'm trying to write. He is prime. I think I need to reboot my computer, but I can't do it in the middle of the video. He is prime, P-R-I-M-E. Okay, example 8. Y squared and 2y are the two terms. GCF is a y, right? The GCF, the common factor, is a y. So we take that common factor, we pull it out. We pull out the common factor, look at what's left. A y and a minus 2. Okay? A y and a minus 2. Is that our answer? You bet it is. That is our answer. Common factor is y. Pull out the common factor. Look at what you have left. We have a y and a minus 2. We're done. All right. You guys will be working on the assignment, and it is found on Canvas this time.